which one of the following, so you've got a multiple choice question, which one of the following values is equal to A? It says if f is continuous at x equals 4. So it tells you where to start looking. It says if f of x is continuous at x equals 4. Alright, as soon as you see those words, the things that should be going through your mind, this is what you should be testing out. These are the things that you should be looking for. This. The limit of the function as x approaches 4 from below has to equal the limit of the function as x approaches 4 from above has to equal the value of the function at 4. That's what it'll have to be, for continuity. That means we look at the limits each side of 4 and see if it's equal to the value of the function at 4. In the event that it is, right, we satisfy all three parts, and then yes, we can say then the function is continuous. Okay, so we'll have a look at these two parts first. Right, f of 4, is it defined at 4? It says when x is equal to 4, the value of the function, here's the function, x equals 4, the value of the function is 2a. Alright, so here we can definitely just put 2a on the end. Okay, but this is still in question here. I don't know whether this is equal to this is equal to this. I don't know that. I don't know yet. I've got to test that out and see. Right, and will it equal then eventually 2a and we can solve for a? Alright, well let's have a look. Up here, this is when x is not equal to 4. That means values of... Yeah. Sorry? LT is my limit. Yeah. Some people use LIM. Yeah? It's okay. Alright, so let's have a look at this one. X approaches 4 from below. Alright, now, we're below 4, less than 4. Alright, so this one here, let's have a look at it. Limit, x approaches 4 from below, and what have we got? Of the function f of x. So what will it mean? The limit, x approaches 4 from below of what? We're less than 4. It's less than 4 if you write that. So we've got to go here, when x is not equal to 4. This part here means x is less than 4, or it means x is greater than 4. Right, we can't tell any difference there. Okay, so what do we have here? It's going to be the limit of this thing. Root x minus 2 over x minus 4. Okay, so let's test the situation out. See what's happening to the function at that particular value as we approach 4. As we approach 4 here, what do we get? Approximately the square root of 4 or 2. 2 minus 2, right, it's a 0 situation. Here in the denominator, as we approach 4, 4 minus 4, it's a 0 situation. This quantity here is called indeterminate. Yeah? Now, that doesn't mean it's undefined or goes off towards infinity. It could be a finite value, but at the moment I don't know what that is. I have no idea. But when we look at the limits situation here, we might be able to determine it, I think, without too much difficulty. Alright, well let's have a look now. What can we do? The limit, x approaches 4 from below. Now, what have we got here? This thing here, x minus 4, is in fact the difference of 2 squares. Right, this situation here, when it arises, what you've got to do is try and cancel the factor in the denominator that's producing the 0. Alright, so we would just go ahead here, try and factorise and get rid of the 0 in the denominator if we can. Alright, so what will we get? We get root x minus 2, and down here it is the difference of 2 squares. It is root x minus 2 times root x plus 2. Alright, now, what can we do? Is it okay here to go ahead like this and just cancel in the situation? Well, let's have a look. Can I go over? Right, this is how you argue. X is approaching 4. It doesn't matter whether it's below or above. Okay, if I put that there like that, that doesn't matter. Right, X is approaching 4. So here, root X is approaching 2. Just taking the square root of both sides because they're both going to be positive. Let's get rid of that. Alright, so root X minus 2 is approaching 0. Alright, but root X minus 2 is not equal to 0. If you say it's approaching the value, then that's what it's doing. It's not equal to the value, it's only approaching it. So as a result here, this thing here is not equal to 0. Now, what that allows me to do is this. I can cancel that and cancel that. Why? Because this thing here is not 0. I'm not dividing by 0, not trying to divide by 0. Alright, so our limit becomes limit X approaches 4 from below, and what have we got here now? 1 over root X plus 2. Alright, so we end up with limit of what? Well, as X approaches 4, here, we're going to equal, let's see, 1 here, as it approaches 4, root 4 plus 2. So it looks like 1 over 2 plus 2, 4. And that's the limit from below. Alright, now, if we have a look at the limit from above, the other end, the limit, X approaches 4 from above, this way, well, it's still, this one here means either this or this, either. So as a result, right, we go through exactly the same argument again. It's the limit of f of x, x approaches 4 from above. Right, so we've got the limit x approaches 4 from above of what? Of this thing, root x minus 2 over x minus 4. Right, this one I can do a little bit more quickly. Okay, so we end up with limit x approaches 4 from above, root x minus 2. This is here again, root x minus 2, root x plus 2. Alright, by the same argument as I've got over here, right, exactly the same one, again, I can do that. And so I end up with the limit, when I evaluate the limit now, the limit of, as x approaches 4 from above, 1 over root x plus 2. Alright, now, you can see yourself. As x approaches 4 here, this is approaching the square root of 4, which is 2, so it's going to equal 1 over root 4 plus 2, it's going to equal 2 plus 2 is 4, 1 4. Okay. So, back here. This value, the limit of f of x as x approaches 4 from below, was a quarter. Right, now when we look at from 4 above, it's a quarter. Alright, but the definition says here both of those have to be equal, and it's got to equal to the value of the function at 4. Well, we've got the value of the function at 4 is 2a. Okay, our two limits are the same. So in order for f to be continuous, we say here, if f of x is continuous, then here 2a would have to equal the evaluation of our two limits, which are the same, quarter. And so we end up with a equals an a. And that's choice number 3.